Hello everyone, so welcome to another lecture. So in this lecture, what we're going to be looking at is muscle mechanics. And so in particular, what we'll focus on is we'll start off focusing on some things related to the way muscles attach to bones and the way that muscles attach to bones and their orientation and their anatomy will strongly influence and strongly dictate how that muscle behaves, so how it contracts, and then the action that muscle produces when it does contract. All right. We'll then move into talking about different types of levers or different classes of levers and lever systems in the body. And then we will kind of end the lecture by talking about different types of muscle fibers based on their appearance and based on their color, based on the way they make their ATP, as well as their endurance and their ability to resist fatigue, right? So if we start, what we're going to start off with is looking at muscle movement and how our muscles are able to generate force and generate tension, all right? So to first understand how muscles move and how they generate force, you first have to understand how they contract, and that's what we talked about in the previous lecture, so chapter 9. Here we're now going to talk about how they attach to bones, and then based on how they attach, how they produce movement. So a muscle has two attachment points generally. One is referred to as the muscle's origin, one is referred to as the muscle's insertion. Normally the origin is more proximal, so it's closer to the trunk of the body or closer to where that limb, so the upper limb or lower limb, closer to where it attaches to the body, and it's typically less movable. So it does not move quite as much. That area or that region of the muscle. And then the other attachment site is called the insertion point. And the insertion is typically more distal, so it's further away from the origin of that limb to the body. And it is typically the more mobile attachment that is actually moving whenever that muscle contracts, right? So a very easy example is if you look at the biceps brachii muscle. So the biceps brachii, biceps means two heads, and brachii is referring to arms. So this is a two-headed muscle on the arm. And so what we see is we see that it has a proximal attachment up on the shoulder, so on the scapula, and the distal attachment or the insertion is the radial tuberosity of the radius. So you have a proximal attachment, the origin, along the scapula, and you have a distal insertion along the radial tuberosity of the radius. So as you look at this muscle, you notice that it crosses the elbow joint, right? So here's our humerus, here's our ulna. This is the humeral ulnar joint, this is elbow, and it crosses this point here. So a common theme in muscle mechanics and what you'll see is that if a muscle crosses a joint, the muscle is going to act on that joint, right? So in this case, our biceps is crossing our elbow joint, so it's going to act on the elbow joint. And what it does is it causes flexion of the elbow joint with a slight supination. So we have slight supination of the elbow or of the forearm, and then you also have large scale flexion of that joint as well, right? So this is just one example, but you could look for any other muscle. You could look at the quads, look at the hamstring, look at the brachialis, look at any muscle, and you'll see it attaches at one point, the origin, attaches at another point more distally, the insertion. One is more mobile, one is less mobile, and if it crosses a particular joint, it's going to act on that joint as well, okay? So along with a muscle, you have other muscles that may assist in the movement. Some may be the main mover, the prime mover of a particular joint for a particular action. Some may kind of assist, and then some may completely oppose the movement altogether. All right. So these are called agonist, antagonist, and synergist muscles or muscle groups. All right. So an agonist, that is the muscle that is, or the group of muscles that is directly involved in a particular action or a particular movement. Right. So when that muscle or that muscle group contracts, you get some movement of some joint, right? So for the biceps, you get flexion of the arm at the elbow, right? An antagonist, if you think of the word antagonist, this is a muscle or muscle group that is opposing the movement of the agonist, right? So anytime you're talking about an agonist or antagonist, you have to be specific to a particular movement, right? You can't just say the biceps is an agonist or the triceps is an antagonist because they're both agonist and antagonist depending on what type of movement you're referring to, okay? So if you're talking about forearm flexion, biceps is the agonist. It is producing that movement. That muscle group is causing flexion of the forearm, causing flexion of the elbow. In that case, the muscle that would oppose that movement would be muscles that cause elbow extension, and that's your triceps, right? So in this case, now if we're talking about forearm flexion, the triceps is against that because the triceps does not result in forearm flexion, but instead it results in forearm extension, right? And then you have muscles that are called synergist or synergistic muscles that serve to kind of stabilize the joint as other muscles around it actually produce the movement, right? So you have biceps brachii, you have the brachialis that kind of stabilizes the elbow joint. It may help, it does help contract it a little bit, but it largely serves to stabilize it. You have muscles around the shoulder, the rotator cuff muscles that move the shoulder joint, but they also help to stabilize it a little bit as well, right? So again, when you're looking at these, always be specific in terms of what uh, what movement or what action you're referring to, because depending on the action you're referring to, a muscle or muscle group may be an agonist, but it may be an antagonist as well, right? So for all of these that are causing some type of movement or opposing some type of movement, we can then look closer at those particular movements or those actions of the muscle, the contraction, and see what happens to the muscle itself, right? So we'll see two things. The muscle can either change length when it contracts, or it will not change length when it contracts, all right? And so we'll look at both of these and we'll call them different things. So the first one we'll look at is called an isotonic contraction, right? Isotonic contractions occur whenever there is a change in the length of a muscle. In some direction, the muscle will either get longer or the muscle will get shorter, right? So whenever you are changing the length of a muscle, you have a difference in the amount of tension that the muscle is producing versus the weight of the load or the weight of the object that you are moving. So there's some resistance from whatever it is you're moving, right? So you have two types here. You have one in which the muscle shortens, and you have one in which the muscle lengthens, right? So if we are shortening our muscle, this is called a concentric muscle contraction, right? Concentric, the muscle is shortening. So if you think to chapter 9, you have those sarcomeres. Those sarcomeres are sliding. They are sliding closer together, one Z disc. They're moving closer together. When one sarcomere shortens, the entire myofibril shortens, so the whole muscle fiber shortens, so the whole muscle itself shortens as well, right? So in this case, this is whenever, an example of this is whenever you are picking something up maybe from the ground or from your waist, and you bring it towards your chest, right? So think of this image to the right of a man holding a child. If that baby was down and his arm was straight, so imagine this arm was straight down here, and then he swung the baby up. He started to flex the biceps. You're decreasing the angle between the humerus and the ulna. You're flexing and you're bringing it up. That muscle is shortening, right? The tension that's generated by the muscle is great enough to overcome the load or the weight of the baby, right? So you're able to pull it up, bring it closer to your chest, the muscle shortens. You can feel this very easily if you have your arm down to your side, you put your arm on your other hand on your biceps brachii, and then you contract that arm that was straight and make it flex, the elbow flex. You can feel that biceps brachii. You can feel it physically shortening, all right? You can then go to the next one, which is eccentric. Do the same thing, have your arm flexed, put your other hand on your biceps, and then straighten your arm out. And you can feel the biceps changing length. But in this case, the muscle is lengthening, and this is called an eccentric contraction. Eccentric. So you can remember E in eccentric, think elongate. The muscle is getting longer. In this case, the load of whatever it is that we're trying to move, a baby or a book or a rock or something, the load is greater than the force and the tension that we can generate with our muscle. So we're still producing tension, right? We're still contracting, but instead of the muscle shortening, the muscle is getting longer because that load is greater than the tension that we are producing with the muscle at the level of the sarcomere, right? So you're still producing tension, but overall, as the muscle is producing that tension, it's getting longer, okay? So this would be an example of whenever you are decreasing the angle between the humerus and the ulna as you're extending your elbow and you're putting something down. So you have your arm flexed near your chest and you begin to decrease the angle, you increase the angle, you're extending and you're putting something down near your waist, right? This is an example of the muscle elongating, it's getting longer, all right? So these are both called isotonic contractions, right? We're generating tone, the same tone, but we're changing length, right? The next type is termed an isometric contraction, right? In isometric contractions, we are contracting, we're generating tension, but we're not changing the length, right? So the muscle is staying the same length. So in this case, the tension that we've produced with our muscle is not greater than, nor is it less than the weight of the load that is the thing that we are holding or moving or something like that, right? So you can imagine if you go up to a door that is closed, you go up to a wall, a brick wall or something, and you begin pushing on that wall, right? You're not moving the wall unless you have some type of superhuman strength. You're not moving the wall. The muscle itself, as you feel it, it is not changing length because the two equalize, right? So the force that is being applied by your muscle against the wall is equal to the wall's force back against your muscle. The two are equal. You have no change in muscle length, right? You can also think of just holding an object out in front of you or holding an object, like in this case here, holding something close to your chest. You would be able to feel the biceps. It would be, in this case, contracted, right? It would be producing tension, but at the same time, the tension generated by the muscle is equalizing, essentially, with the load, or the weight of the load of what it is that you're holding, right? So in this case, the baby, right? So you could also think of like an arm wrestling match in the example here, right? One person is pushing from right to left, one person is pushing from left to right, and the two forces, the two amounts of tension being generated by each individual's biceps is roughly equal, so there's no movement, right? You're not pushing their arm down, they're not pushing your arm down, okay? All right, so if you think about these ideas of muscles contracting and they get shorter, they get longer, all of these different ideas, they all have to do with different characteristics of a muscle, right? So because a muscle has characteristic X, it behaves like something else, right? So one characteristic is contractility, right? This is what we talked about in chapter 9. The ability of our muscles to actually contract. Now, we typically refer to it as getting shorter, right? Sarcomere shortens, zetas slide together, and that's what you see in the animation to the right. Although it's not always that, as we've just seen. Sometimes the muscle gets longer, sometimes it doesn't change length at all. But in this case, we're generating some type of tension, right? So our filaments are going to slide past each other. The myosin head is going to pull the actin past it, okay? Now, when we're talking about movement of joints and muscles contracting and moving joints, the muscle attaches to the bone via tendon, right? So that tendon is made of dense, regular connective tissue that blends with the periosteum of the bone. And when the muscle contracts, pulls on the tendon is attached to the bone, which pulls the bone, okay? So your muscles also have this feature, this characteristic of plasticity, right? They can constantly adapt to different tensions and different forces that cause them to stretch, right? So our muscles are also excitable, right? They're an excitable cell. They're able to respond to an electrical stimulus. They're able to send and propagate an action potential down its length. And so we looked at in chapter 8 the action potential, and then in chapter 9 how you relay that action potential over onto a skeletal muscle cell, right? You also have extensibility, right? So extensibility is the ability of our muscles to stretch, so they go from one length to some other length. And as we saw in chapter 9, there's not always a continual increase in the amount of tension generated by a muscle as you increase the length of the muscle, right? So it does increase to some degree, and then it begins to taper off, and the tension begins to go down, all right? Along with extensibility, you also have elasticity, right? So elasticity has to do with the idea that our muscles can stretch, they can be distended, right? So they're extensible, like we saw here, but they also can return to their previous shape or return to their previous size, right? So just like a rubber band, you can stretch it and then let go and it returns to its original length, and you stretch again and you release it, it returns back. So too can our muscles do the same thing, right? But also, just like a rubber band, you can pull it to the point where it breaks and it can't return back. We can also pull muscles as well, right? So you've heard of pulled muscles or strained muscles. We overextend them, we overuse them to a point where they stretch beyond their normal physiological limits, okay? All right, so we'll stop right here, and then we will pick up with part 2 in our next part.